Hello, I'm Matt Dossie, and this video is about the query module in NetSuite SuiteScript 2.0. I should start out by saying that I'm recording this in May of 2019, and the current NetSuite release is 2019.1. So what I'm about to tell you and show you might be outdated by the time you see this. Please consult the latest documentation if anything you see here doesn't check out in practice. At this point, the query module documentation is being updated pretty frequently, and all of this is very new. While I'm giving out warnings, let me just say that none of this is endorsed by NetSuite or Oracle. If I offer an opinion, it is my opinion, and if I make a mistake, it is absolutely my mistake. I don't have any inside information beyond what's publicly available. Okay, with that out of the way, let's get right to it. What is the query module? The query module is a new module in the SuiteScript 2.0 API, and it sits in parallel with the search module, doing much the same thing. It is tightly coupled to the Suite Analytics Workbook feature that has just been released from beta, and it's tied to that in the same way that the current Save Search module is, or Search module is tied to the Save Search feature in NetSuite. If you want to load and run a Save Search, you use the Search module. If you want to load and run a workbook, you use the Query module. So the next logical question is, why would you want to use the query module over the search module? To be brutally honest, you probably don't, at least not right yet. For pretty much everything you're going to need, the search API is going to be a more practical solution for you for the near term, just because there's a massive amount of documentation around it. The error messages are very familiar to us and very human readable. It's a much more mature set of functionality, and it's going to do everything you need it to do. It's not going anywhere anytime soon. It's a pillar of the platform. At the time of this recording, at least, there's really only 3 good reasons I can think of to start using the query API. The first is that it's new and shiny. It's got that new module smell, and for like me, that's enough to get you to pick it up and play with it and see what it can do. It's not a great reason, but my guess is if you're watching this in 2019, it's probably the reason that you're here. The second reason is that you've been tasked with writing a script that uses the output of a workbook. If that's the case, you're really in a corner, and the only thing you can do is use the query module. That's the only way to get to that information from a workbook. And the last reason is that you're going to have to learn it eventually anyway. The writing is on the wall. All the new features that users need, like multi-level joins, outer joins, pivots, increased expression depth, a really slick user experience, built-in visualizations, all that stuff, it's just not going to be released to searches. It's going to be released to the workbooks. As a developer, you need to learn the API that's powering that new technology, because that's just the way the wind's blowing. Okay, so with that said, what's the best way to wrap your head around this new API? What's the key piece of information that's going to help you to understand what this API is? Well, for me, the aha moment was when I learned that the query module has a main purpose of distilling your input into a SQL statement. So SQL, or SQL, it stands for Structured Query Language, and it's not new. It's almost as old as computer science itself. And it's how most databases have been accessed for years. If you've somehow never been exposed to SQL, this won't mean much to you in and of itself. But the takeaway here is that the query module operates on a much lower level, closer to the database than the search module does. The search module, I think, was created to be very user-friendly, and it did that at the expense of the expressivity and the power of the lower levels of the stack. Query module accesses that power and still manages, or tries to manage, to be very easy on the UI. The particular flavor of SQL that is used is called And wait for it, ready? SuiteQL. As of this moment, the really enlightening parts of the API are not included in the documentation, but we're going to take a peek under the covers in our coding exercise, and you'll see how you're going to create a SQL statement and actually run that statement against the database, just like we've done in countless other languages before if you've been in the computer science industry for a long time. Speaking for myself, that knowledge brought the rest of the API into focus and gave me a much deeper understanding and appreciation for the query module. And after writing a few scripts with queries in them, I found myself kind of disappointed and frustrated when I couldn't use the query module. And why couldn't I use the query module? Because the data source doesn't quite reach all the corners of NetSuite yet. There are joins that aren't there. I've found, at least recently, that a custom transaction column field that referenced a record didn't have a join to that record like it would in a search. And that was difficult for me to, once I couldn't do things like that, I certainly had to back up and fall back to the search module. I want to try to avoid that if we can, and my advice to you is that you're pretty safe if you are working with an intricate network of custom records that all link to one another, and you're not traveling too deeply into the structure of native records. If you think you're going to have to go pretty deep into, access some pretty obscure joins and native records, you might think about just using the search module until you're sure it's going to work, or allowing yourself extra time to be able to start down that path and then back up and start again down the search route. If you need the documentation for where all the links are, the record browser is not going to help you. The best you're going to do is a spreadsheet that's kind of buried deep in NetSuite Help. If you go to NetSuite Help and search for available records, or you search for the query module and find available records on that page, you'll see a link that takes you to a spreadsheet, and that spreadsheet is fairly well updated with the current schema supported by the query module. Well, hopefully that's helped you'd get some perspective into the query module, but you probably came here hoping to see some code, so let's get right to it.
Okay, let's take a moment first to look at the output of a Suite Analytics workbook, which gives us some customer data, and then the equivalent customer search, which gives us that exact same data. So we'll start with a search here. The search has one filter. It's under the criteria tab of the sales rep's birth date. We want a sales rep whose birth date is sometime in the decade of the 60s, between January 1st, 1960 and January 1st, 1970. And the results we expect are just some basic information about the customer: first name, last name, company name, phone, email, and who the sales rep is. We just preview this, and we see we get some results here. In the workbook, we do the same thing. We have one criteria where the sales rep's birth date is within 1/1 and 1/1/1960 and 1/1/1970, and the output is very much the same. First name, last name, company, phone number, email, and sales rep. Everything is as we expect here. A couple things I want to point out about the Suite Analytics workbook interface here that may not be immediately obvious. First, in order to get that criteria, I actually had to create a join to the sales rep. So in the customer, I had to click this and find a join for the sales rep, And once I had that, I could then search against the sales rep's birth date and get this criteria here. Okay, it's important to note, and you'll see why in this script a little bit later on, but that join had to be defined first before I could get to that data. Unlike with the search API, which is over here, if I go to this, in the criteria, I just had to go to, as you're probably aware, you'll scroll down to the join fields, which have this ellipse here, and find the sales rep. And then that sales rep then immediately gives you access to the birth date, which we could then select. So that's a key difference, but it's important. Also, while we're talking about this customer query in the workbook here, it's not immediately obvious how you get to the ID of this, this workbook. However, this little I here, this little symbol, you click that, it does give you the ID. Unfortunately, there's no way that I've found to specify an ID for a workbook, unlike with a search where you could not only specify the ID at the outset, but you could also come back in and change the ID later with a change ID button. This I can specify the ID, make it make sense so that as I'm looking at it in the script, I can see what it is. I can also click change ID and update that. Cannot do that with a workbook. So I'm sure that's functionality that will eventually surface, but until then, we don't have it. Okay, so what does that mean for our scripting? Now we could write a script that uses or constructs these two objects, the search and the query, and then returns the exact same data just as we've done in the UI. And then we can use that to kind of compare and contrast the two APIs. So I've done that, and I've created a Suitelet. It just renders this page right here. And if we just look at the way this page is rendered, we've just got a real simple output, no header information, two sublists, a query results sublist and a search results sublist that both are driven by the search criteria and columns that you saw in those two user interfaces right there. The query results over here and then the search results over here. And they are the same. There are some key nuances to them though. First of all, you'll notice that at the outset, search results are by default given a sort of internal ID. So just as we refresh the page, with no sort really in place, search results are by default seem to be coming in from the internal ID. The query results, not so much. The internal IDs here are expressed as a number, a floating point number, which is a little unusual. I wasn't really expecting that, but that's the way it is. There's no inherent search at all. It seems to, or sort of at all. It just seems to be more or less random. 41 is up here, 39 is down here, 11 is here, 15 is here, 14 is between them. That doesn't make any sense at all, but that's how it is. But if we do sort by internal ID here, force that page to sort by internal ID, we can easily see that these two are bringing back the exact same data otherwise, with the exception of that 0.0 at the end of our internal ID, which is strange. Okay, so there's that. Now let's look at the code that made this Suitelet happen. I'm going to open up my WebStorm here and just share with you what it took to get this, and maybe have a little conversation about what's happening here. So I guess let's start at the bottom. So the on request, when we get a request, if it's a get request, we do this handle get function. Handle get is just going to write a page, and we're going to call the render form function. The render form function is right here, and all that does is creates a form, calls it query and search, adds a sublist, calls it query results, and adds another sublist, calls it search results. Define some columns here for the query sublist. I cheat a little bit here, I guess. I just copy that same object with a JSON stringify wrapped up in a JSON parse. And then I replace all these these IDs here. Instead of saying query, they're just going to say search now. So I create an identical sublist in essence for the search subtab. And I'm adding the actual columns to the form here, to the sublist, for both the query list and the search list. And then here is the real heart of it. We're getting the data. We're running this function, which is called getData, and it returns an object that has a property called query and another property called search. And each of those contains an array of the results in a pretty specific format. And then we return we actually use those results to populate the data in those sublists, query and the search respectively, and then we return the form. So that's the top level stuff, but the get data is where things get really interesting. At this point, I'm calling two separate functions, get data by query and get data by search. Let's look at search first because we're familiar with that, and that should be easy to just see what's going on and identify what's needed. Again, this really duplicates what we saw in the UI. We defined an array called data, and that's what we're going to return. The filters are also an array, and columns are an array. If you're anything like me, you do these a lot, you can do them in your sleep. It's just you're creating a filter, you push the filter onto the filter list, and you create some columns. I've got this technique where I kind of create columns as named objects. And then I just loop over the named objects and push them onto the column array, and then I create the search, and then as I'm iterating over the results, I can call these actual names as call data call, and then I can sort of name these properties and put the results onto an object. I then push that object onto a list, and I return that list. So the search is pretty vanilla. I think everybody's written something like this. I do want to call out, though, that in the search API, I really have to pass in these values for the dates as strings. I could use the format module to do that, and I honestly probably should. This being a kind of a down and dirty demo, I just passed in the hard-coded values of those strings. But that's important a little bit later on. If I try to pass in dates here, it would throw an error. This API, the search API, does not accept JavaScript dates as a filter here. Okay, so moving on to the really fun stuff here. This is what you paid for your ticket for, the get data by query. In this case, I'm going to return the same sort of data. It's going to be data as an array. I've got filters, but I'm actually going to define those as an object. And then I've got this other thing called joins, and I'm defining that as an object too. I could just define a separate variable for each join. I find that a little bit too disorganized for my taste, but to each his own. Rather than creating a separate variable for each filter, a separate variable for each join, which is kind of where the documentation goes, I'd rather group those under an object and then call those from the filters and the joins object respectively. So our first real element here, our first component, is the root. and that's the customer query. So we're creating a query by defining a variable for it. We're using the query module itself, calling its create method. We're giving it a query, a type of customer. It's important to note that the query types are not the same as the search types. The enumeration is a little bit different, so always, check what the actual enum is for the query module when you're using that. Don't try to just pass off the search module. I don't think it will work 100% of the time, although I'm sure there's a lot of overlap. You really have to join or define your joins ahead of actually needing them. So unlike with SuiteScript or SuiteScript search module, where you just kind of threw the join in there when you created the search or the filter, and it just worked, here you've got to do a little work ahead of time. You said, hey, I'm going to need this join for a column or a filter or something, and it then becomes available to you later on in the code. So I'm defining start date and end date here as new dates with those specific values. Those are JavaScript dates now. And then down here, as I'm creating this filter, or rather a condition, it's not really a filter in the query terminology. In this condition, I could pass in that same string I passed into the filter, the search create filter API, but I could also pass in the native JavaScript date, and that's a beautiful thing. I love being able to use native JavaScript functions and objects rather than having to reinvent the wheel. And it's always really irked me to use dates as strings anyway. But so that's in my mind at least an improvement. So bringing us back up to here on line 201, I'm creating these variables for the start and end date, and then here I'm defining a named filter called birth date, and I need information from this join in order to make this condition. This condition is based on the sales rep, not the customer. The customer is the root record here. That's the customer. That's the record we're starting from. We need to actually go through this join to create a condition, and that's why we have to do this. The join as a member of create condition, and that's where we define the field ID, not name, but field ID is the birth date. Operator is query operator within, and we'll talk a minute about query operators here real quick too. Let's just take a look at what that means. I'm going to flip over here to my console and just take a look at what these query operators are. These are really unusual. They're not what we're used to, not the same thing. So you're going to have to unlearn your operators from search in order to use the proper ones in query. It seems like every operator has a not version after and after not. Before and before not, greater or equal not, which is really hard on the ears if you love the English language, but it is what it is. So just be sure to use the right operator when you're working with the API. So anyway, getting past that, we've got values in here, and we pass those the same way, with the exception of this field ID. We're really kind of in the same like search.create filter API as far as the parameters go. Field ID replaces the name parameter in that place, but otherwise it looks very, very similar. Now columns are, they're made in sort of the same way as you see in a search. You're creating an object with a field ID instead of a name, and it has that field. One thing that's interesting about the query API is there is no like default concept of result.id like you'd find in a search result from the search API. You actually have to ask for the internal ID explicitly, and the internal ID is not internal ID, it's just the word ID, as you see here. Internal ID will throw an error, so it's not a valid column. You have to actually use ID. Little nuances there. Otherwise, these are pretty much the same. First name, that's the field ID right there. Last name, etc. Company name, all that sort of thing. Sales rep here, I don't actually need to use my sales rep join to get that because I'm not looking for the birth date of the sales rep. I'm only looking for the sales rep's ID in this case. So I've defined these columns as objects and named objects, just like I did for the search, but you'll notice here I'm actually getting an array, which is each of these keys of this call data property as a member of that array by calling object keys call data. And the reason for that's going to be clear in a couple of lines. I'm iterating over the call data objects here, and I'm taking this customer query and it's got a columns array, just like a search object has. And I'm going to push onto that array each one of these columns by calling, again, the method of this root object, create column, and then this object right here. So I'm iterating over this. I'm actually pushing columns onto my customer query object. Now, one thing to note here is if I had any columns that did use a join, like I needed to bring back the sales rep's birth date, for instance, I wouldn't be able to use this same method to do that. I would have to have a new line, and it would look something like this. So you see, in this case, I would have to have, instead of using the customer query to create the column, I need to create the column from that join. And now the field ID of birth date is in the context of that join. So it's the sales rep's birth date. And I'd be reporting on that. And that would then be, oh, it looks like number 8, the 8th column in this array here. But I don't need this, so I'm going to get rid of it. And let's move on to the next thing. So here, even though I've created the condition by calling it, adding it to this filters object, filter birth date is a new condition. I need to actually AND it together onto this root. So here's the root object. Its conditions are sort of, well, its conditions are part of the SQL query. So we use this API called AND method off the root query to add any filters together joined by ANDs. If there were ORs in there, we could actually call that method within the ANDs to sort of duplicate what we see in a filter expression on the search API. The results, we run this customer query.run.results, and that gives us an array of results. Run gives us a result set. Results are a piece of that set. So each of these results has a property called values, and those values are it's just a simple array of uh, of column values. And the way those look, it's just dead simple. You're used to a save search that comes back with a sort of a get values function and a get text function, and you could interrogate, is it a value? Show me the display value with the get text. You can call those, the get value in the search API will accept an object, or it accepts the name of the column that you're bringing back, plus any joins or summary properties, and it'll return that value. What you get in the query API is just an index. You have to reference these by index. So you have to know that column 0 is the internal ID, and column 2 is the first name, and column 3 is the last name, and column 4 is the company name, etc. So that's why I needed to get the column sequence up here to get each of those properties. So what I'm doing down here is I'm creating, I'm iterating over the results, and every result I'm creating this object called line, and then I'm iterating again over the column sequence, which is a list of these property names. And for each one of those, I'm assigning a named property value, the result of that index, whatever that index is. And then I push that onto an array and I return true, and then so that the search can continue, and I return the data. So that seems pretty simple. Let's see it in action and really get into how this looks. Just gonna grab the heart of this function here, everything but the declaration, signature, and the return. And I'm just going to put that over into the console. Just take a look at some of the things that we have going on here. Let me go ahead and execute this in the console. And let's take a look at what this object looks like, this customer query. Okay. It's got some methods here that are documented, and there are some that really aren't. I want to draw your attention to that one right there, to SuiteQL. This is not in the documentation, but let's take a look at what this does. This is really quite cool. So I call customer query equal dot to SuiteQL. It gives me an object, and that object has a query parameter, a query property, and it's got an array of parameters, array of columns. Those are the columns that we put on there. But really, that query is what I want to draw your attention to. So that's what that looks like. If you're from the DBA world, this is going to look super familiar to you. This is a select statement. In SQL, this is the heart of how you read databases, by these select statements. You'll notice the sort of raw designation there. That means we're bringing back an ID rather than a text value if it's a related record, and that doesn't mean anything at all except for that last column. The sales rep is the only one that's list record, and that would be an ID versus a text value because it is raw. But these comments here are just kind of built in. and I don't know that changing those is going to change any kind of functionality. It looks like it's just commented. It's just for our humans' benefit of understanding it. What's interesting is you could run this. The output of this, by the way, is right here. I'm just going to give you an idea of what that looks like when the API runs. Each object in this array looks like this. It's got that named column that I've given it, and it's got a value. And in the case of this one right here, there's no first name, there's no last name, it's just a company name. This one is the opposite. Gary Kimball doesn't have a company name, he's an individual. But each one of these just has a named property, and that's enough for our Suitelet to match that up to the column ID that it should be, and drop it in that list. But what's interesting too is that if I take that SQL statement, let's say it's take that statement, and then I also just call the main query module. There's a method called run SuiteQL, which is also not well documented. I feed it that same statement. It's going to give me a result set, and that result set's going to have results, and those results are the same as we got by running this function up here, customer query .run .results. These are the exact same results. So you could actually just feed a SQL statement to that function and not have to worry about creating criteria, creating joins, all those other things. The entire module then becomes a convenience to help you compose that SuiteQL statement and run it. And that's all I have for you for an introduction on the query module. If you've already purchased my book on LeanPub, you've already got access to the sample code you saw here in this session. You can just navigate to the book in your LeanPub account. Click on this little link here to see it in your library. Find it in your library, and then click this download extras. You'll find about 500 kilobytes to date of goodies in there, including all the code samples that are in the book and all the code samples that I've shared on YouTube here. So if you haven't purchased the book yet, you might think about doing that. You can just Google NetSuite development. I'll be probably on the first page, or go to leanpub.com and search from there. If you haven't subscribed yet to Eric Grubaugh's channel, it's a great idea to do that. And you can always catch me and sometimes Eric on the NetSuite Professional Slack channel. So if you're not familiar with that, reach out to the comments and somebody will point you in the right direction. Hit subscribe if you like to see more content like this, and we'll be sure to produce it.